Hey everyone, and welcome. Today we're diving into something you've probably seen 100 times, the fizz of a bath bomb. It seems so simple, right? But that bubbly explosion in your bathtub is actually a super fascinating chemical reaction. So let's unpack the science behind it.
It's a great question. You drop this solid ball into water, and suddenly, poof, it just erupts in this crazy fizzing spectacle. But what is actually going on there? Is it some kind of magic, or is it pure chemistry? Well, today, we're going to solve this mystery, one clue at a time.
You know exactly the scene I'm talking about. The solid sphere hits the water and immediately starts dissolving in a total flurry of bubbles. That fizzing, that bubbling, that's our number one clue. It tells us a gas is being produced, and our mission is to figure out exactly where it's coming from.
Okay, let's start our investigation. The first and most obvious clue is the bubbles themselves, which leads us straight to our first big question. Where did all that gas suddenly appear from?
So we have two competing theories here. The first idea suggests the bath bomb is kind of like a sponge, just holding on to tiny pockets of air that get released in the water. The second idea is a bit more dramatic. It suggests the gas doesn't even exist until the bath bomb hits the water, that it's being created brand new right on the spot. So, how do we test this?
Here's a really clever way we can figure this out. First, we seal a bath bomb in a bag and get a precise weight of the whole system. Then, we crush that bomb into a powder, but we do it inside the sealed bag. See, if the gas is just trapped air, crushing it should release it, but it would still be inside the bag. Finally, we weigh it again to see if the total mass has changed at all.
And the results are in. The mass doesn't change one bit. 0 grams lost. This tells us something absolutely crucial. Simply crushing the bomb doesn't release any gas. The fizz doesn't happen when it's dry, only when it's wet. This is really pointing us away from that trapped air theory.
So, here's our first major breakthrough. Since crushing the dry bomb did nothing, that first claim, the idea of trapped air, is pretty much out. The gas isn't just being released. It has to be something new, something that's being created only when the bomb gets wet.
Now, you might be thinking, hold on, how can new matter be created? Well, it's not being created from nothing. This is where a fundamental rule of the universe comes into play, the law of conservation of matter. It basically says that matter can't be created or destroyed, it just changes form. The atoms that make up the solid bath bomb are just rearranging themselves to form a new substance, our mystery gas.
All right, on to the next part of our investigation. If the gas is being created from the bath bomb's ingredients, our next job is to figure out which ones are responsible. It's time to identify the suspects.
A typical bath bomb is made of a few common substances. We've got baking soda and citric acid, which are both just white powders. Then you have binders and fillers like Epsom salts and cornstarch, and maybe some oils for fragrance. These are our primary suspects.
Not all of these ingredients are actually involved in the fizzing. Some are just there for scent, or color, or texture. Our job now is to isolate the exact combination that produces the gas when you mix it with water.
So we can test them. By combining the suspects 2 at a time in water, a super clear pattern emerges. Most combinations do nothing. But look at that! When you mix baking soda and citric acid together in water, you get bubbles every single time.
And there it is. The code is cracked. We found our reactants. It's not just one ingredient, but a team of 3. Baking soda, citric acid, and the trigger that gets it all started, water. This is the core reaction that drives the entire fizz.
We're so close. We know how the gas is made, but we still don't know what it is. This is the final piece of the puzzle. Let's finally identify this mystery gas.
Based on common chemistry, there are a few likely candidates. It could be something flammable, like hydrogen, or something that supports fire, like oxygen. It could be lighter than air, like helium, or heavier, like carbon dioxide. We just need to run the right tests to find out.
We're going to use 2 classic chemistry tests to identify our gas. First, the flammability test. We'll collect the gas and see what happens when we expose it to a flame. The second is a density test. We'll see if the gas sinks or rises in the air by trying to pour it over a candle.
And here are our results. First, the gas immediately puts a flame out, so it's not flammable. Second, when we pour the invisible gas out of a container, it actually sinks downwards and extinguishes a candle. That means it's definitely denser than the air around it.
Okay, now we can play detective. It's not flammable, so we can cross hydrogen off the list. It puts a flame out instead of feeding it, so oxygen is out. It's denser than air, so light as a balloon helium is eliminated. That leaves just one prime suspect standing.
The mystery is solved. The fizz, the bubbles, the whole eruption from a bath bomb is all caused by the production of carbon dioxide gas. It's the same stuff we exhale and the same stuff that makes your soda bubbly.
So let's recap and put the official scientific language to what we've discovered. This isn't just about mixing things together, it's something way more fundamental.
What we've been witnessing this whole time is a classic chemical reaction. It's a process where the starting materials, called reactants, are chemically transformed into entirely new substances, which we call products. The atoms are literally rearranging themselves to form new molecules.
And this slide really summarizes the whole story. On one side, we have our reactants, baking soda and citric acid. When they combine in water, they transform into the products on the other side, the carbon dioxide gas we identified, along with other substances that get left dissolved in the water.
So, why does this matter? Because understanding this one simple reaction actually opens the door to understanding countless others. The principle of reactants turning into products is a cornerstone of all chemistry. So, where else might we see it in action?
Think about the famous elephant's toothpaste experiment. That incredible eruption of foam is also caused by a chemical reaction that rapidly produces a huge volume of gas. In that case, it's oxygen. It's the same principle as the bath bomb, just on a much bigger scale. It just goes to show, once you start looking for it, you'll see chemistry absolutely everywhere.